Hey guys, I showed you earlier how to add a text object to the scene so that we can increment time forward using a clock containing the time and date. But we also want to be able to schedule events from that. And so for that, we're going to have to do a little bit of coding. So I thought I'd just show you a very brief example of how I implement some event scheduling. Yeah, let's take a look. So we've got our text object in the scene, and it has has the time manager script attached to it. No values in here just yet, so we'll have the default values, but the increment speed is set to 1, and we're set to increment by minute, so time will move forward on the minute value every real world second at the moment. And if I just click play to show you that's working, maximize that, you can see it's got a very rough text object floating around, and it's moving up on the minute every second. Now I've added a schedule button, and the reason for that is that I want to be able to click that and then have an event queued for the future to run. And we do that with some coroutines. Basically, we use coroutines to pass in a future date and a text object that we want to measure against for that date. So basically saying when this text object reaches this date and time, run this code. So we're just delaying the execution of that code until a future time. And those coroutines will live in one class, one game object called Job Manager, and that is here. So you'll need the Job Manager game object to be in your hierarchy. This will be the central hub, if you will, for any jobs that you schedule. And it does it through a script which is attached to it, and it's called Job Scheduler. Now you won't need to add this script or create this game object. When you import the asset, you'll get a prefabs folder, and you can just go to the Job Manager, drag it in, and you'll have the game object, and the script will be attached. And it's that script where we'll have our coroutines. And so obviously you'll have your own code, which is doing specific things, like it could be a character script, or it could be something to control pathfinding, or anything to do with something within your game. But within that code, you'll suddenly have a need for some other code to run in the future. That's the use case. So I, for example, use this in my game for ships arriving at a space station. I say that when a particular thing happens, make a ship spawn in 3 in-game hours, for example, and it does that. And so it has the ability to call the Job Manager, the script attached to the Job Manager, and execute a coroutine that I've implemented. So I'll show you the coroutine class, the Job Scheduler class. It's here. And when you import the asset, you'll get this example commented code, and it contains one coroutine. It's called Run Job, and all you'll have to do to implement a future event, to give yourself a coroutine to be able to call to schedule the job, is just copy this coroutine and uncomment it, and you'll have what I've added here, which is the same thing without the comments. I've kept the same name. I've kept the parameters. These are the minimum parameters you will need for the coroutine. And everything down to this comment, the add code to run here, this is also required. And it's already there for you, so you don't need to touch it. And then further down in the coroutine, you have this comment that says add code to run here, and you basically take whatever code you want to run in the future, and you add it in here. So I'll just quickly go through what the coroutine does so that you get some idea of how it works. The first parameter for it is a string called job date time. It is essentially a string representing the future date and time as it would look in the text object, and we're passing that in so that we can use this function down here to suspend execution of the code until the time and date is the time and date that we've specified. Now, you might also want to be aware that you could use multiple text objects in the scene. You might have several different clocks. You might have one running as a stopwatch. You might have one running as a global date time value to represent the in-game world time. But there's only one coroutine class. So you will have to pass in a reference to the time date object you want to use to measure this future time. So you're essentially saying, I'm passing in this text object. When this text object reaches this date and time, we want to run this code. That's from a high level, that's how this is working. So for me, I only have one time date object, so it's not a big deal. I just pass it in along with the future date and time. In terms of the code that I'm running for this example, the future event, so to speak, I'm just very simply saying log this text to the console, job running. Very basic event, but for you, you might have a method in another class that you want to call, or you might have several different functions. It's totally up to you. Realistically, you want to be using void methods, but you can use anything that would be within scope or something that is possible to call from this coroutine when it runs at that time. So let's look at how we would call this coroutine, because whenever you start the coroutine, you are essentially saying, schedule this job. I want this job to run in the future. So I'm going to go over to this class that I've created. It's called extrapolate and schedule. Pretty convoluted name, but it wouldn't obviously be called anything like that in the real world. It would probably be, like I said, a character script or something that controls some other behavior in the game. And it's a domain in which you would suddenly have a need to schedule an event. So there's a few references that you would add. For the purposes of this demonstration, I've added a button reference. So we're going to need a button to actually demonstrate this to you, scheduling the event. I've made that public so it shows in the inspector. We've got another public reference of type text, which is a date time text reference. You'll always need this. This is the text object that we want to reference in terms of time. Again, we'll use this to pass into the coroutine later on. And another thing you'll always need is a reference to a game object, public one, so we can see it in the inspector, and that is the job manager. So as I mentioned before, you have a job manager game object in the hierarchy with the job scheduler script attached where we have all the coroutines, and you'll need to be able to reference that in any of your code so that you can access the coroutines that are attached to the scripts attached to it. When I say script, it's just one script, the job scheduler. So before I go into these other references, I'll just show you that the references are in the hierarchy. If I go to the button where we've attached my class, you wouldn't always have a class attached to a button. It could be attached somewhere else as a component, but for the purposes of this, it is attached to the schedule button. And you can see the public references I've added: test button, date time text, and job manager. And I've simply dragged over the references. So for the test button, it's the button we want to click to schedule the event. The date time text I've dragged over. Sorry, go back. And the job manager is the game object I've just dragged over. So we have links to those. Now the references which are not public are these here. I've got a reference of type job scheduler. I've just called it job scheduler with a lowercase j. And I've got a reference of time manager, again with a lowercase t, called time manager. Now these are references to scripts that we need to access. Now, you wouldn't necessarily always need to access a time manager script. If you remember, the time manager is a script which is attached to the text object, which actually makes it a clock, makes it a date time object. But for this demonstration, I will be accessing some functions within that script, and I'll go into more detail in that soon. What you will need, though, is the ability to access the job scheduler script, and that's the script, as I said, attached to the job manager within the prefab. So you will always need this. So we're going to need to initialize these references. So I'm doing it in the start method, so because it will start on initialization of the class, so it will be initialized. The first thing I'm doing is just linking the button to a method, and the method itself will schedule the event. It will start the coroutine. So I've got a test button, which is the button reference, and I'm just adding an on-click listener to run task in future, which is my method, when I click the button. And while I'm talking about run task in future, you can see here, this is the method that will be called, and this is calling the coroutine in the job scheduler script, but I'll go into more detail on that in a moment. So the other references that we're initializing, we've got the time manager reference we added here, and what we're doing with that is using get component on the text object to get the time manager script. And if you're not familiar with get component, you will need it for Timekeeper, as well as some knowledge of coroutines. So I do suggest that you look to have a basic understanding of coroutines and get components within the Unity scripting API. But if you are unsure, there's documentation on the website, and there's also documentation in the form of a README with your project. And of course, you can always contact me as well. I'm happy to get in touch and explain some the features in more detail. So we have the time manager link, and then we have job scheduler. We're activating this reference here by, again, using get component on the job manager game object, and we're grabbing that script that's attached to it. So with these two references, we now have access to those two scripts. So back to run task in future, where the actual work will be performed. So when we click the button, we are starting a coroutine, and that coroutine is in the job scheduler script, which we created reference for. It's called run job, as we can see here. And then we've got two parameters to pass in. Like we said, we've got the job date time string, the actual time of the event in the future, and we've got the reference to the text object. So you can see here that this is laid out in exactly the same way that it would look in the text object. And then we have the date time text variable containing the text object. So that should now mean that whenever I click that button, it will run this coroutine. And that when we hit January 1st, 2018 at 12:15 or midnight, 24-hour clock, it will run this code. It will print job running to the console. There we go, we can see that a bit clearer. So I click schedule, 15 minutes past. There we go, we have job running. Just had a little issue with the console display. So I'll just do that again for you so you can see. I'll clear the console. I think it was these weren't activated, so I'll just press play. And get the console again. Click schedule, 15 minutes past. There we go. So yeah, that is how we would do it. Now, one of the things that is a little bit of a pain is that we wouldn't always know how this would look. We might just want to spontaneously say, I want to run something in 3 hours or 3 minutes, and I don't know what that time will be, but I just want to be able to do it. And we have some functions for that, and that is the reason we've added this time manager reference. So I'll just stop execution on that. So instead of passing in the literal string, we can access a time manager script. So I'll use the reference we added, and I will access a function called future date from minutes. And this requires a parameter of an integer, and we'll say in 5 minutes. So you can use this function to return the string as it would look in, say, 5 minutes time. And there are several others that we can use. If we look at the time manager script, we've got future date from days, we have future date from hours, future date from minutes, seconds, and obviously you can go further than days. Say you wanted to do 4 weeks, say 6 months, a year. You just use these functions and pass in the relevant value to get that future date. And that saves you having to work out the string beforehand and allows you to be a little bit more dynamic about the way you schedule your events. So I'm going to use this now to make the printout on the log happen 5 minutes into the future whenever I click the schedule button. And so let's just want to build on that, just make sure that's okay. Yeah. So I'll press play. So we're moving forward on the minute. And so no matter when I hit this now, it should give me the text 5 minutes ahead in the future. So I'll hit schedule on 15 so that we get it at 20. So 18, 19, 20, and there you go, job running. So you can obviously use these functions to extrapolate a string representation of the date and time in the future. There are a few things that could trip you up in this. Obviously, if you try to predict the future date in seconds at the moment, you would see an error because we don't have seconds to increment with. So if you're incrementing by minutes or hours, it doesn't display seconds. I can change this so that I'm incrementing by seconds and press play, and you will get a seconds value. Just move this a little bit more, go into 2D, and there you go, we have an actual seconds value and we're incrementing on that. So you'd be able to extrapolate a future date in seconds. So there are lots of different ways you can predict future dates with those functions, but they do depend on how you're incrementing. So I hope that helps, but for now, that's everything. Thank you.